Alright guys, so in section 11.6 we're going to continue to talk about measures of angles and how they relate to a circle. Now let's first of all just kind of remind ourselves of the two angles that we've looked at so far. The first of which is what are called central angles. Central angles are when the vertex is in the center of your circle, and remember that when that's the case, that the measure of the angle, in this case the measure of angle 1, is the same as the measure of your arc, which in this case is x. So those are directly related to each other. If the measure of angle 1 is 30 degrees, then the measure of arc x is 30 degrees, and so on. Inscribed angles, we found out, were a little bit different. In fact, we found out that they were 1/2 of the measure of our arc. In other words, if you're looking at this diagram, if you look at the measure of angle 2, that would be equal to 1/2 the measure of arc x. In other words, if arc x was 120 degrees, then measure of angle 2 would be 60 degrees, and so on. So now let's go ahead and talk about some other angles that you can see when looking at a circle. The first is going to be an angle which is formed by a secant and a tangent intersecting at the point of tangency. So here's what that would look like. So when you have an angle which is formed by a secant, so the secant would be this line that I've got outlined for us here in blue, whereas the tangent would be this line that I've got outlined here for us in red. And notice that they intersect one another at the point of tangency, in other words, where that line in red touches our circle and intersects it. And when that happens, the angle that's formed is going to be half the measure of the intercepted arc. In other words, the measure of angle 3 in this case is going to be 1/2 the measure of arc 3. Or rather, the measure of arc x. I don't know why I said 3. Okay, so let's take a look at some examples of this. In this first example, what we'd say is that the measure of angle x is equal to 1/2 the measure of our arc, which in this case we know is 60. In other words, the measure of angle x is 60 divided by 2, which is 30 degrees, and there's your answer. Now for this next example, notice that we're not given the arc, we're not given this arc in blue that we would want, but we are given some other information on the circle. We're told that the other arc is 310 degrees. So if we take 360, which is the entire circle, minus that 310, that tells us that the measure of that arc that we would have wanted to know is 50 degrees. And then we can go ahead and set up the rest of our equation. So we said the measure of our angle x is going to be 1/2 multiplied by the measure of that arc, which is 50 degrees. And 1/2 of 50 is 25 degrees, and there would be your answer. Okay. The next type of angle we're going to talk about is the angle that's formed by two secants or two chords intersecting in the interior of the circle, but not at the center. And so that's kind of the difference. So when an angle is formed by two secants or chords intersecting in the interior of the circle, but not the center, it's going to be half of the sum of the measure of the intercepted arcs of the circle and its vertical angle. In other words, if we were going to look and find this measure of angle 6 right here, it would be the average of these two arcs. So you'd take arc CD, so the measure of arc CD, plus the measure of arc AB, and if you're finding the average of those, you just add them together and divide by 2, or multiply by 1/2, however you would want to write that. Okay, so let's look at some examples of that. So in this first example, we're asked to find the measure of angle SPQ. So that would be that angle right here. So to find that angle, we're going to go ahead and add together our two arcs. So that would be 38 plus 112, and we're finding the average, so divide that by 2. That's 150 divided by 2, which then simplifies to just be 75. So the measure of that angle looks like is going to be 75 degrees. Okay, so this next one, it looks like we're going to be working backwards. So we know what the measure of our angle is. That's 38 degrees. To get that, we know we would take our two arcs, which are 36 and x, and add them together and divide by 2. So this time we're going kind of backwards from what we did on that first example. So then, let's go ahead and do this. Let's go ahead and multiply both sides by 2. That'll get rid of the fractions. So now we'll have that 76 is equal to, these 2's are going to cancel, 36 plus x. So to get x by itself, just subtract both sides by 36. And that's going to tell us that 40 is equal to x. There's the measure of that arc. Okay. So for this next example, let's do this first. Before we solve for x, let's solve for this missing angle. And then we can talk about how to use that information to get x. Let's go ahead and just call that angle y for right now. So remember, to get y, we would take the average of our two arcs. So that would be 110 plus 95, and then divide by 2. So that's going to be equal to 205 divided by 2, which we'll just have to use a decimal. 102.5 is what we should get if we divide 205 by 2. So then keep in mind that when you look at x and y, they are supplementary, meaning they add up to be 180. The reason we know that is that they create a straight angle. They create a straight line when you put them together. In other words, if they have to add up to be 180, if you take 180 minus that 102.5 that we know is y, that should leave us with 77.5 left over for x, and there would be our answer. Okay. The next type of angle we're going to talk about is an angle that's formed by two secants intersecting outside the circle. And so when you want to do that, an angle formed by two secants intersecting outside the circle, it's going to be half of the difference of the measures of the arcs in the interior. So rather than adding them and dividing by 2, you're going to subtract them and then divide by 2. In other words, if we wanted to find the measure of angle 7 in this case, we would take our arc AB, so the measure of that arc, minus the measure of arc CD, and then divide that by 2. So again, kind of a similar formula, but using subtraction instead of addition. Okay, so let's take a look at some examples of that. For this first example, to find the measure of angle x, we've got all the information we need just to go straight into using that equation that we were talking about, that formula. We're going to take the measure of the larger arc, which is 100, minus the smaller arc, which is 50, and divide by 2. That's 50 over 2, and then that's 25, and there would be our answer. For this next one, we're only given kind of one of the arcs that we would need. The 130 we obviously are going to be using, but it'd be nice if we knew what this arc was right here. And to find that, let's just take our entire circle, which is 360, minus the other arcs that we already know. So minus 100, minus 130, minus 90, and that's going to be 40, which is left over for this arc right here. Now we should have all the information that we would need to find the measure of angle x. We're going to take our larger arc, which is 130, minus the measure of our smaller arc, which is 40, and divide that by 2. So that becomes 90 divided by 2, which is just 45. Okay. So this last one, we're going to have to work a little bit backwards. If we kind of set up our equation, we already know the measure of our angle, which is 59 degrees. And we would have found that by taking 160 minus the smaller arc, which is x, and then dividing that by 2. So first thing we'll do to get rid of the dividing by 2 is that we'll multiply both sides by 2. That's going to be that 118 is equal to 160 minus x. So then we'll subtract 160 from both sides. That's going to leave us with negative 42 is equal to negative x. And then if we want to switch that around, either multiply by negative 1 or divide by negative 1, or the easiest thing to do is just switch the signs on both sides. And that's going to be that 42 is equal to x. And there's going to be our missing variable. All right. Our next type of angle is an angle formed by the two secants intersecting the outside of the circle. So when you have an angle that's formed by two tangents which are intersecting outside the circle, it's going to be half of the difference of the measure of the intercepted arcs. So kind of similar to what we were doing before with secants, let's go ahead and kind of illustrate an example of this, and then we'll look at some more examples. So in this, we're going to say that the measure of this angle 8, which is formed right here, is going to be our larger arc, which is AB. Let me do that in a different color here. So that would be the measure of arc AB minus the measure of arc AC, which is the smaller one right here. And then divide that by 2. And that should be our angle. So again, a very kind of similar formula if you think about it to what we were doing before. So let's go look at some examples. So we're told that the measure of the smaller arc is 60. So to find the larger one, let's take our entire circle, which is 360 minus that 60. So our larger arc is going to be 300. So then to find the measure of angle X, we're going to take our larger arc, which is 300, minus the smaller, which is 60, and divide that by 2. That's going to be 240 divided by 2, which is going to be 120. And there's the measure of our angle. Okay. So in this case, it wants us to work backwards. We're told what the angle is. Let's go ahead and call the larger arc X. And since we don't know what the smaller arc is either, we would find that by taking 360 minus X. And so then that will be what we'll do to find the smaller arc. Okay, so if we set that up in an equation, we know that the measure of our angle, which is 100, would be equal to our larger angle, which is X, or a larger arc, which is X, minus the smaller arc, which is 360 minus X, all of that divided by 2. So let's do this first. Let's go ahead and multiply both sides by 2. That way we'll get rid of the dividing by 2. So now we've got that 200 is equal to X minus, in parentheses, and make sure those parentheses were there, 360 minus X. So let's then go ahead and distribute that minus sign. So that's going to be a minus 360, but a plus X, because a minus a negative, which changes that to be a positive X. So now we can put our variables together. X plus X is 2X. So now we've got that 200 is equal to 2X minus 360. So now let's go ahead and add 360 to both sides of the equation. So now we're going to have that 560 is equal to 2x. And now finally, to get x by itself, just divide both sides by 2, and you're going to get that 280 is equal to x. So now we can go back and put those into our original diagram. So if x is 280, then that becomes this arc right here. And then remember, for the smaller arc, we have to take 360 minus 280. That's 80 for this smaller arc, and there are the measures of our two arcs. All right, one last angle that we're going to talk about, and then that should be it for today. So this last one is an angle that's formed by a secant and a tangent, which intersect this time outside of the circle. So we've already looked at where a secant and tangent were together, but they're intersecting on the edge of the circle. Now they're intersecting outside the circle. And when that happens, it is half the difference. And I think there was a typo in there, but yeah, half of the difference of the measures of the intercepted arcs. So make sure that you somewhere write that word of difference, add that into the definition. But again, this is going to be very similar to what we've been doing on the previous examples. So once again, if we wanted to find the measure of angle 9 in this case, we're going to take our larger arc, which is CB, minus the smaller arc, which is AB, and then divide that by 2. So again, a very similar formula to what we've been using on these last couple of sections. All right, so let's take a look at some examples. So for this first example, we already have all the information we would need. We've got 140 as the larger, 60 as the smaller. So to find the measure of angle X, take your larger arc, which is 140, minus the smaller arc, and divide that by 2. That becomes 80 divided by 2, which is 40. And there's the measure of our angle. For this next example, we aren't given all of the information we would need, but to get the measure of this missing arc that we would want, not too hard to do that. Just take 360 minus the other two arcs, so minus 80, minus 120. That's going to be 160, which is left over for the measure of this arc. And now we should have all the information we need. So the measure of angle X is going to be equal to our larger arc, which is 160, minus our smaller arc, which is 80. Divide that by 2. That becomes 80 divided by 2, which is 40. And there's our final answer. All right. One last example here for us to look at, kind of a working backwards problem. This time we know the measure of our angle, which is 59. And we're looking for the measure of our larger arc, which is X. So we would have taken X minus 42 and divided that by 2. So first thing we'll get rid of is the dividing by 2. So we'll go ahead and multiply by 2 on both sides. That'll be that 118 rather is equal to X minus 42. And then to get X by itself, just add 42 to both sides. And we'll get that 160 is equal to X. All right, guys, I think that about wraps up all of the different types of angles we could see. So in the next section, we will start to take a look at lengths of segments. Until then, have a great rest of your day.